Hey guys, welcome back. So today we're looking at average rate of change. Now an average rate of change is going to be over an interval. Okay, so average rate of change, average is key, but it's over an interval. We're looking at a specific piece either of our graph or a specific section of our data. So there's a couple different ways, a couple different scenarios that we can do this. So first it says, how can we find, again, look at that keyword, average rate of change over an interval when given a graph? Well, average rate of change, this is also known as slope. Okay, hopefully that word is familiar to you guys. So if you've heard of slope, we have an expression that we use, and it's called rise over run. So when we're determining the slope of a particular line or a particular section of a graph, we're actually finding the average rate of change just amongst that interval. So looking at our first graph, we're given the interval -1 to 1. Now remember, how do we read a graph? From left to right. So when it's talking about -1 to 1, that's looking at our x-axis. So -1, there's our start point, 1, there's our ending point. So identify your 2 points. So -1, 2, and +1, 5. I want to find the average rate of change or the slope between these 2 points. So I'm using rise over run. So again, left to right, rise over run. How are we going to get there? So we're going to rise, we're going to go up. Let's see, 1, 2, 3 units. And we are going to, from here, run. I'm going to the right, that's a positive movement. So I'm going to run 1, 2 units. So +2. So my slope is identified by the letter M. So rise over, I did not make that up, I promise. So rise over run, we rise 1, 2, 3 units. And ran 2. So our slope, or our average rate of change, just for this specific, section of our graph is 3/2. Okay, now let's look at this one. Again, feel free to pause the video if you want to try it on your own. So from here, my interval now is 0, 3. So reading left to right, I'm going to start at 0 and we're going to end at 3. So we're looking at this particular section. So I'm going to identify my 2 points on the graph that are at 0 and 3. So left to right, I want to know, how do I get from 0, 4 to 3, -3? All right, so rise over run. Well, how many am I rising? I'm not going up at all to get to that next point. I'm actually going down. Wow, how many did I just go down? Let's see. Remember, don't start counting until you go to the next point. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Yep, all right. So I'm going down 7. Now, since I'm going down, that is directional, so I'm going to denote that with a -7 because we're going down 7. Does that make sense? And then we're going right, so that's in a positive direction. So we're going to go right 1, 2, 3. So +3. So our slope, or our average rate of change for this one, is -7 over 3. So when given a graph, rise over run is a pretty nice tool, pretty quick and easy to just find rise over run to find your average rate of change. So when given a graph, no problemo. Now, this one, notice, below is a graph and a table for 2 runners running the 400-meter hurdles. All right, so we're doing 400-meter hurdles. It's a graph and a table, so this is both pieces are representing the same information. However, one might be a little bit more useful than the other, just depends on what they're asking us. So let's go to that first question. Which runner has a faster average speed for the first 9 seconds? I'm going to underline that. So for the first 9 seconds, which runner has the fastest average speed? Well, let's see. For the first 9 seconds, so where do we start? 0. Where are we ending? 9. So if I look at that piece of my graph, well, both runners are starting at 0 because 0 time has passed. They haven't run yet. And when they stop at 9 seconds, they're both at the same place. So which runner has a faster average speed? Neither. They both have the same average speed. So both runners have the same average speed for the first 9 seconds. So from 0 to 9 seconds. Cool? All right. So which runner has a faster average speed from 9 to 20 seconds? Okay, so now we're looking at different pieces of the graph. So from 9 to 20 seconds, so just these two sections. All right. Now my problem here is that, yeah, they're both at 20, but I'm not exactly sure what my y values are. I see it's above 150, so maybe like 160, I don't know. Above 200, I'm not really sure. So which runner has a faster average speed from 9 to 20 seconds? Well, don't forget, we're also given the data. So from 9 to 20 seconds, runner A is at 9:120. Remember, they both were at the same place. So runner A went from 9:120 to 20:168. Ooh, I'm glad I didn't guess because I was close, but I was not right on it. And then runner B went from the 9:120 to 20:213. So who had a faster average pace? If we can't see that on a graph, what we can do is we can use a formula. So slope also has a formula. It's y2 minus y1 over x2 minus x1. Okay? Ultimately, what this is saying is the change in y divided by the change in x. So that delta symbol, that means change. So change in y divided by change in x. So if I start off with runner A, okay, runner A has, we start off at 9:120 and we end up at 20:168, so 168 seconds. Then for runner B, I'm going to leave myself some room. Same thing. We're both starting at that 9 seconds, and they were both at the same spot of 120 meters. And then runner B at 20 seconds is at, come back up here to my table, 213. So if I want to use this formula, I like to go ahead, since I'm already starting with the y's, the change in y, I like to underline my y's. Now notice as it says y2 minus y1. You don't have to do it in that order. What's important is that however you subtract your y's, whichever order you use, you have to do the same for your x's. So I'm going to look what's easier to me. So if I look at this, I say, okay, 168, I want to take 120 from that. That's going to be nicer. Now, since I started with 168, I have to start with 20 on the next one. So 20 minus 9. All right, so 168 minus 20. So 68 minus 120 gives me 48, divided by 20 minus 9, so over 11. So 48 divided by 11, because 48 elevenths doesn't mean much to me. So if I'm looking for the average, well, average speed, right? Distance divided by time. Okay, so average speed, so 48 divided by 11, I'm just going to round to the nearest hundredth. So I get a long decimal, so I'm going to round to the nearest hundred. So 4 and 36/100 meters per second. All right, that sounds pretty darn fast. Let's look at runner B. So runner B, again, I'm going to start off with my y's because it's change in y. So I want to subtract 120 from 213. That looks easier to me. So 213 minus 120 divided by 20 minus 9. So again, it's out of the same. It's out of the 11 seconds. And 213, subtract 120, leaves me with 93 meters and 11 seconds. So when I do 93 divided by 11, I'm going to get about 8.45 repeating, so about 8.45 meters per second. So let's go back to the question. It says, which runner has a faster average speed? So 4.36 meters per second or 8.45 meters per second? Who's faster? Yeah, 8.45. Faster. We want a larger number. So runner B definitely has the faster speed for that specific interval. So just from the 9 to 20 seconds. Because the next question asks us, which runner wins the race? How do you know? Okay, if I look at my table, 287, 287, well, that's not very helpful. Because how far is our race? Our race is 400 meters. So which runner wins the race? Well, let's go find 400 meters. So runner A, how long does it take runner A to get to that 400 meters? If I follow this down, like maybe 38. So 38, 400. And what about runner B? 50, 400. So who runs the race faster? Do we want, now let's think about it. Speed, who runs the race faster? Do I want larger numbers or smaller numbers? Well, I'm talking about time. So whoever wins and runs it the faster. So that's the least amount of time, right? So who wins? 38 or the 50? Well, runner A, it takes 38 seconds to reach that 400 meters. And runner B, it takes 50 seconds to reach that 400 meters. So who won? Runner A won. How do we know? Because they ran it in the least amount of time. All right, I'll put this over here. So runner A wins. How do we know? They finish the 400 meters in the least amount of time. Cool. So you've just looked at two completely different scenarios. Sometimes we're given a nice little graph so we could use rise over run. These numbers were not as nice. They were not as clear. So sometimes you have to look at a data table to then use your slope formula to find that average rate of change. Remember, why is this related to slope? Because it's average rate of change. So it's over a specific interval. Well done. Go find a couple problems. Try these on your own. Let's see how you do.